Okay, so I'm doing your review sheet. The first one. This one was on the class website, so not the one I gave as a handout. Let's see if I can. So first one, it says use an integer to represent each situation. State what 0 we represent in each situation. So if this was a quiz, it's probably worth 1 point each. A profit of 300. It's right. You're making 300, so 300 plus. And what 0 would mean is what you make no money, right? So makes no money. So if you had a profit of $0, you probably didn't make or lose any money. Okay. 45 feet below sea level is going to be negative 45 as an integer, and 0 would be the surface of the water. Surface. When back 10 spaces, negative 10. And if you got a 0, you mean you stay where you are. You not go forward and you not go backwards. Stay where you are. Go up 12 floors is plus 12. And if 0 would mean you stay at your current floor. Stay in current floor. Current floor. Okay. Number 2, we're going to find the absolute value. So the absolute value of negative 34 is 34. Okay, if you were on top of negative 34, you would have the distance between negative 34 and 0 is 34. Okay, that's the distance. And remember, distance can't be negative. Over here, let's do the bottom one. Absolute value of 5 is 5. Plus absolute value of negative 7 is 7. And you get a total of 12. You got to take the absolute value before you do the addition. Over here, that minus sign does not interfere with anything yet. So you have to first take the absolute value. So if you take the absolute value of 14, it's 14. And then that minus sign has to be put next to it. So the answer is minus 14. This one says 3 times absolute value of negative 23 minus 10. So we can't multiply. Remember I told you that the operation between 3 and the absolute value of negative 3 is multiplication. So we're going to leave that. We're not going to do the multiplication yet. We're going to take the absolute value first. It's going to be 3 times absolute value of negative 23 is 23, right? Because negative 23 is 23 units away from 0. And then minus 10. Remember order of operations? We do these two first. Multiplication comes first. And 3 times 23 is 969. And now we subtract that from minus 10. And you get 59. So the answer to this question would be 59. Determine if the numbers are counting, whole, integer, etc. Okay, so 1 second. Okay, so here we go. And 5, it's a counting number or natural number. Counting belongs to that. It's also a whole number. It's also an integer. And it also belongs to the rational. Negative 14, it's not counting, it's not whole, but it's definitely an integer. Integer. And it's rational. Negative 2.75 is not counting, not whole, not integer, but it's definitely a rational number. Negative 3/8, it's not counting, it's not whole, it's not integer, but it's a rational number. Okay? Now, the bottom ones here, you want to put them on a number line. So I would first create a number line. Let me see, from 0, I would need a 1, right? Because I know here it says 1. And I'm going to need a 2 because this number is going to fall between 1 and 2. Negatives, I'm going to go negative 1, definitely need it. Negative 2, definitely need it. Negative 3, definitely need it. And I don't need negative 4 because there's no number that's going to be between negative 3 and none. So let's do the easy ones. 1.15, $1.15. This is 0. 50 cents would be right here. $1. $1.50 would be between 1 and 2. So $1.15 should be just about here. And I'll write 1.15. The other one that's easier, negative 1.75. So start counting from here. 0, 50 cents, sorry, negative 50 cents, negative $1, negative $1.50, and negative $1.60. And it should be about here, negative 1.75. And finally, we can do negative 2.9. 0, -1, -2, -2.5, -2.6, 0.7, 0.8. -2.9 should be very close to 3. Okay? Now pause this again. And he's trying to finish. So -2.9. So here you are at 0, right? So let me just change colors. Here you are at 0. And you just start, you know what? Just start counting. 0. If you want to count, obviously don't count by 0.01, otherwise it'll take you so long. But maybe count by 50 cents. 0, -50 cents, $1, $1.50, $2, $2.50. And if you go a little bit more than $2.50, you'll eventually hit $2.90. So think of 2.9 if you want even as -2.90. Now the other two, notice this one, I'm going to circle, and this one I haven't done because I want to change that to a decimal. It might be easier. So I'm going to take -2 4/7. So this is going to be -2 point something. Well, 4/7 is a little bit more than half, right? So to be precise, let's divide 4 divided by 7. 7 goes into 4 0 times, add a decimal, 7 goes into 40, I don't know, 5 times, 35. 5 down, bring another 0 down, 7 goes into 50 8 times, 7 times, which is 49. And I'll stop there because we don't have to be that precise. So 0.57, so -2 and 4/7 is 0.57 continued. So that gives me an idea. So as I told you before, it's a little bit more than half. So that's just, again, if you want to think of numbers, money, $2.57. Well, here's $0, -$1, -$2, -$2.50, and -$2.57. It's going to be just a tad more over here. That's the location of that number. -1 1/8 is going to be -2 and 1/8, so it's going to be -2 and a little bit, maybe about 10, 11. So let's divide 1 divided by 8. 1 goes to 8 0 times, add a 0. 8 goes into 10, sorry. 1 time, 8. 2 left over. Bring another 0 just for us to go 2 decimal places, and 8 goes into 24 times. So I'm going to stop there. I'm going to put the 0.14. So 2 and 1/8, it's approximate, close to -2.14. So here's $0, -$1, -$2, and -2 is 14/10. It's just a little bit more. So I'm just going to reach that over here. Okay. And my numbers are ordered in least to greatest now. -2.90, -2.57, -2.14, -1.75, and 115 on that side. Okay? Again, I have to pause this. So, let's move on to the next question. Now, this one says compare using less than, greater than, or equal, 1 point each. So, again, -3/4 and -5/6. I would change them to decimals. Okay, so that's what I would do. Okay, to make life easier if you're unsure. So -3/4 as a decimal becomes 0.75. Negative. -5/6. You're gonna actually have to divide, right? Numerator goes here, divided by 6. 0. Add a decimal. 8. 48. 2 left over, bring another 0 down, so 6 goes into 23. So let's just stop there. So 0.83. So that is 0.83. Negative. So now you have a better representation. Now, so if that still doesn't help you, you can put them both on a number line. Here's 0. Let me put 0 a little bit to the right because I don't need the positives. Here's 0. So as you're walking, 0.1, 0.2, 0.10, 20, 30, 40, 50, 60, 70, 75. 0.75 would be the first number you hit, negative. Keep going, 76, 77, 78, 79, 80, 81, 82, 83. And here is 0.83. So, which of these two numbers is the bigger one? I told you that on the number line, the number on the right, which in this case is this guy, is always bigger than the number on the left. So, negative 0.75, which is -3/4, right? Because this is now write the fraction equivalent on the top, and -5/6. So out of the two numbers, which one is the bigger number? Okay, it's negative 3/4. So negative 3/4 is definitely greater than negative 5/6. So that's one way of doing it. Okay, remember with decimals, okay, sorry, no, with the negative numbers, okay, the bigger the number gets, the less it's going to have in value, right? This one, 23.45 and 23.4, if that confuses you, I would suggest you make them equal looking, so add a 0 here. With decimals, I like to think it about money. Here I have $23.45, here I have $23.40, and $23.45 is definitely bigger. Okay, let's do the easy ones. Absolute value of negative 19 and 19. Well, absolute value of negative 19 is 19, right? Because negative 19 is 19 units away from 19. So once I take it, I can say that 19 is equal to 19. Negative 29 and negative 28. Do you think negative 29 is greater or less than negative 28? Well, let me put them on the number line. Oops. A better looking number line. So that's 0, and you start walking in that direction. Negative 1, negative 2, 3, 4, 5. Negative 28 is probably going to be here, and negative 29 is going to be that way, right? Because negative 29, think about it. If you ask yourself that question, if you were to walk back to 0, which of these two numbers is a little bit further away from 0? Negative 29 is a little bit further away from 0, which means it should be more to the left. So the number that's bigger is this guy, negative 28, right? Because the number on the right is always bigger. So what can we say about negative 29? Negative 29 is less because the number on the right is always bigger. Negative 15, this is a negative number. This is a positive number. And negative numbers will always be less than. Okay. And finally, the last one, negative 5.6. And the other one is negative 5 and 2/5. Negative 5 and 2/5. So let me change 2/5 into a decimal. 5 does not go into 2. Add a decimal, add a 0. 5 goes into 24 times. So negative 5 and 2/5, it's going to become negative 5.4 or 0.4. So I'm going to change this for a second and write negative 5.4. So is negative 5.6 greater than negative 5.4? No, it's not. It's less than. Okay, if you do it on a number line again, here's your 0. As you start walking that way, 5, 1, 2, 3, 4, 5, 5.1, 5.2, 5.3. You're going to hit 5.4 first, 5.5, 5.6. Who's on the right? This is, which makes him bigger. So negative 5 over 6, negative 5.6 is definitely smaller than negative 5.4. The temperature on Friday was a cold 12 degrees. On Saturday, the temperature dropped 20 degrees and then went back up 15 degrees. Why do I feel like we did this? What was the temperature on Sunday? Explain how you got your answer. So, one thing you can do is, hang on a second, guys. Oh. Yep, here we go. So, I can draw a number line. Okay, so I can draw a number line that's up and down. I can draw a number line that's, only because I have more room here. I'll go like this. So you're 12, here's 0. I'll make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's where 12 is. And negative 1, negative 2, negative 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Negative 15. 1, 2, 3, 4, 5. I don't need to draw these. I just say I'm 6, 7, 8, 9, 10. I don't know why. So 12. You were at 12 degrees, positive, and you dropped. So a drop is go left or go down. In this case, we're going to go left. So think about it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And if you drop 20 degrees, you end up here. And that's what? Negative 5, negative 6, negative 7, negative 8. This is and negative 8. So on Friday, you were at 12, Friday. On Saturday, you dropped 20 degrees, and from 12 to drop 20 degrees, you end up at negative 8. On Sunday, from negative 8, you go up 15. So let's go from negative 8. Let's go back up 15. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You can do that. And that ends up at 1, 2, 3, 4, 5, 6, 7. On 7, you get 7. Okay, so your temperature on Sunday was 7. That's one way of doing it. It's a long way of doing it. The other one is understanding, maybe I'll do it up and down. Here's your temperature right now, 12 degrees. Okay, I'll make this 0. And it dropped 20, so I know it's going to drop all the way, and I know it's going to drop 20 degrees. So from 12 to 0, right here, it's a drop of 12. But I know I have to drop 20 in total. So far I've dropped 12. From 12 to 0 is a drop of 12. I still got 8 more. There's my 8 more. If I'm at 0 and I drop 8, where do I end up? I end up at negative 8. All right, so there's my drop of 20. I go up 15, so I know I'm going to go back up 15 degrees. Well, from 8 to 0, I go up 8. To go up a total of 15, I need to go up a 7 more. So if I'm at 0 and I go 7 more up, I should end up at 7 degrees. Okay? Which is what I do end up with. Create a number line to show the 3 rational numbers that exist between -7 and negative. So first of all, let me do this. So imagine where your 0 is. So if your 0 is somewhere over here, 0, -1, -2, -3, -4, -5. I'm going to hit -7 first, right? And here's -7.2. So I want you to come up with 3 rational numbers, any 3 rational numbers that exist between these 2 points. Well, make this a 20. I think it helps you guys if I do that. So that's 7. And this is 7.20. Or think of money. -$7 is -$720. Well, what would be between 7 and 720? Well, the easiest rational number, I think, would be this one, right? What's right after $7? Well, you can say, well, -7.01. You can then make a case for -7.05. There's so many numbers you can put between 7 and 20. About the one right before 7.20, -7.19. The one right after 7.10, 7.11, negative. Okay, so these are just a few examples of some of the numbers you could have put up. I have an odd feeling that I've done this before. Explain why -5 and 5 are opposites. They are opposites because they're equally distanced from 0. So imagine if this is 0. 1, 2, 3, 4, 5. That's 5. -1, -2, -3, -4, -5. Why is this -5 and this 5? Why are these numbers opposites? Because if you count their distance away to 0, well, this is 5 spaces, right? Right here, 5 spaces away from 0. And guess what? This is also 5 spaces away from 0. So they're opposites because they're both equally distanced from 0 to 0. Okay. Next one, from least to greatest. So the smallest number is -73. That's the furthest all the way to the left on the number line. Okay, so if you put these now, -45 comes next, -8, and then it's 5, and then it's 21. Oops, I forgot a 0. Sorry, let me go back. -8, a 0, a 5, and a 21. So these are my orders. So look, that was a number line, right? That would make sense. Okay. The number to the right is always bigger. 21 is bigger than 5. 5 is bigger than 0. 0 is bigger than -8. -8 is bigger than -45. And -45 is bigger than -73. Write the decimal equivalent. So this one, I actually want you to take some time. And let me do 11 and 12 because it's a little bit easier. Explain how to find the opposite of -18. Well, we just discussed that opposites are equally distant, right? So if this is 0, and just for a second, this is -18, and this is, let me just put 18. The opposite,
Just say hello.
So, sorry, we were talking about opposites. All right, so finding the opposite of negative 18. Well, first I have to draw this just to make so that you can understand. Here I am on negative 18. What's the opposite? Let's take one opposite. The opposite of negative 18 would lead us to what? To 18, right? Because 18 is also 18 units away from 0. So the opposite of negative 18 takes us to positive 18. But we got to take another opposite. And so we find the opposite of 18, and we have to find the opposite again. And that leads us back to negative 18. So the opposite of negative 18 is negative 18. Find two numbers that have the same absolute value. Explain why. Explain how they're related to each other. Well, two numbers that have the same absolute value. Well, let's take absolute value of negative 3. And I'll draw a number line here. That's 0. Negative 3 is here. It's 1, 2, 3, right? So the distance from negative 3 to 0 is 3 units. Remember, distance can't be negative. So, and then the absolute value of 3 is also 3. Let's see why, because 3 is on this side. The absolute value of 3 would be 1, 2, 3, because it's also 3 units away from 0. So two numbers that have the same absolute value would be negative 3 and 3 have the same absolute value, which is 3. They're both 3 units away from 0. So, and how are they related to each other? Well, they're related to each other because they're opposites. Okay? So here I'm not going to divide, but I'm going to show you what your answer should be. Okay? If it says write the decimal, blah blah blah, write the decimal equivalent to the following fractions. If it's a repeating decimal, use a bar notation on the number that repeats. If it's not, then round to the nearest hundred. So if you were to divide 3 divided by 8 and you took your time, you would get 0.35, and it would be a terminating decimal because it would end right there. But it says here, if it's not a terminating decimal, we're going to round this, and this rounds up to 0.38. Because remember, we're rounding to the nearest hundreds. We're going to cut that off right there, and that 5 makes that jump to 38. 5 over 6, if you were to divide, you notice it's going to be a repeating decimal, and you would get 0.833333 forever and ever. So put a little bar notation on top of the 3. That indicates that the 3 repeats forever and ever. 4 over 5 is 0.8. Okay, some fractions like this one, the fifths, everything cuts in fifths, any cuts in fourth, and even everything cuts in thirds, you should know by heart. 3 divided by 7. Okay, so I don't know what the repeating number is in this one. Hang on a second. So, well, if it's not a repeating number, and this one is a repeating number, almost I should have been careful. I phrased this because the repeating part in 3 over 7. Okay, so if you did this and you got 0.428571 blah blah blah, and you continue, you say, okay, this doesn't repeat. It does repeat, but you just have to go really, really far. And keep adding the zeros and keep dividing. I would accept 0.2. So if you continue dividing and you said, oh my God, this goes on and on and on, and you stopped right here, you can round this, and this becomes 0.43. So what happens, and now let me just do this one. This one is 0.66666, or 0 is bar notation like that. 3/4 is 0.75. The repeating part was 3/7, and I assume nobody did this, but if you actually divide, take the time to divide 3 divided by 7. 7 does not go into 3, put a 0. 7 does not go into 3, add a 0. 7. How are you?
How come we lost the last game?
So, back to this. So again, if you were to divide, 7 goes into 30 3 times, 4 times. Somebody didn't teach me more. 4 times, and I'm going to pause this again.